Hello everyone, this is Dr. Maitreyi. Welcome back to the series of lectures in nephrology. Today we will be discussing about the approach to your ABG or your arterial blood gas. So what is the ABG? ABG basically stands for your arterial blood gas analysis. So what is the use of this ABG? So the use is that this is a diagnostic procedure which is used to determine the acid-base imbalances in the body. So it is a diagnostic procedure which is used to determine the acid-base imbalances in the body. So what is the procedure of this ABG? So what do you do when you do an ABG? So basically you take a blood sample from the artery. You take a blood sample from the artery and the preferred artery is your radial artery. So you take a blood sample from the artery and the preferred artery is your radial artery. Now before you go ahead and puncture the radial artery and take a blood sample for an ABG analysis, you have to do something called as the modified Allen's test. So what do you do in this modified Allen's test? Let us understand that this is your hand. So you have your radial artery here and your ulnar artery, right? So you know from the basics of anatomy that this is your arterial arch which is formed this way. So the basic funda of doing this modified Allen's test is that you should ensure that the blood supply to the hand is maintained and there are enough collaterals to maintain, because if you puncture one artery and if that is the only artery which is patent, then you can cause ischemia to your fingers, right? So how do you do this modified Allen's test? So you put pressure on one of the arteries, you occlude, let us say, the radial artery, and you remember that the ulnar artery is free. So you occlude the radial artery. So for example, this is your patient's hand, you occlude the radial artery. So what will happen? The blood flow to this part of which area is supplied by the radial artery is occluded, but the flow will be maintained by the ulnar artery. Similarly, you do this procedure on the other side. You occlude the ulnar artery and see if the flow is maintained by the radial artery. So if this is good, that means that when you occlude one of the arteries, the flow is maintained by the other, the color of the hand does not change and the color is well maintained. So this means that both the arteries are patent. So modified Allen's test is done to ensure that the both arteries are patent and you do not cause any untoward damage, because when you take in an ABG and if the radial artery is the only artery which is patent and that also goes into spasm, then you have a risk of ischemia. Okay. So what are the contraindications to an ABG analysis? So severe peripheral vascular disease or the presence of active Raynaud's phenomenon. Severe peripheral vascular disease or the presence of active Raynaud's phenomenon is an absolute contraindication to an ABG analysis from the radial artery. But you can use certain other arteries including your femoral artery, but the preferred one is your radial artery. Okay. So once you have done your Allen's test and you have seen that there are no contraindications to taking your ABG, then what do you do? So what is the needle that is used? The needle is a 21 gauge needle. Okay. And this is flushed with 0.5 ml of 1 in 1000 heparin. So the syringe is taken, it is flushed with 0.5 ml of 1 in 1000 heparin, right? So what is the use of this heparin? It ensures that the blood does not clot immediately. Then what you do is you palpate the radial artery with the 3 fingers and you take the sample at an angle of maybe 30 to 45 degrees. Okay, and you put in the ABG needle till you see some amount of backflow. Once you see some amount of backflow, you know that you are in the artery and you take the sample. Ensure that there are no bubbles. Okay, you ensure that there are no bubbles and then you feed on this blood to the ABG system which analyzes the ABG for you. Okay, so this is about your steps in your ABG analysis. Okay, fine. Now let us understand the normal values for your ABG analysis. So what are the normal values? The normal pH is between 7.35 to 7.45. The normal pH is between 7.35 to 7.45. The normal PCO2 is between 35 to 45 millimeters of mercury. What are the normal bicarbonate levels? It's a range of 22 to 28 milliequivalents per liter with an average of 24. This is an average of 40. Okay. So these are the normal values which you have to remember it as a mantra. Okay. Now let us go on to the steps in the analysis of your ABG. The step 1 is, once you have obtained your ABG report, you identify the primary acid-base disorder. So, for example, let us say that these are the values you have obtained on your ABG. pH is 7.1. So, what is it? It is acidosis. Okay. So, is this a metabolic or a respiratory acidosis? Look at the bicarb. The bicarb is also low. So, what is this? This is a metabolic acidosis. Okay. This is a metabolic acidosis. So, what should be the PaCO₂? Whenever you have a metabolic acidosis, so the PaCO₂ should also reduce as a compensation. Here the PaCO₂ is around 35. The PaCO₂ is around 35, which is around the low normal limit. So, the PaCO₂ is around 35, which is around the low normal limit. This is how you identify your primary acid-base disorder. So, let us look at the next example. Here the pH is 7.6. That means what? There is alkalosis. That means what? There is alkalosis. Then what happens to the PaCO₂? The PaCO₂ is reduced, right? The PaCO₂ is reduced. So what do you think is the primary acid-base disorder? So this is a respiratory alkalosis. This is a respiratory alkalosis. And what do you think should be the bicarb? As a compensation, there will be renal compensation. So when there is respiratory alkalosis, the bicarb should also reduce. You know that the normal bicarb is how much? Just now we have learned it is around 22 to 28. What is the bicarb here? It is 18. So it is compensating. So it is compensating, and this is what we expected, right? So the bicarb should have reduced. So it has reduced. Alright. So this is how you identify your primary acid-base disorder. So the first step is your identification of the primary acid-base disorder. Now the step 2 will be to identify the compensation. So this table we have already discussed in your basics in the approach of ABG. You can go through that once more. This is just for reference. We will be looking at some numericals to help you understand the compensatory mechanisms. So let us look at the first example. Here the pH is 7.1 and the bicarb is 16. So what do you think is the primary disorder? The pH is low. The pH is low and the bicarbonate, normal bicarbonate is 22 to 28, average 24. So bicarbonate is also reduced. So what is this? This is a metabolic acidosis. Okay, this is a metabolic acidosis. Now, what should the PaCO₂ be? What should the PaCO₂ be? In a primary metabolic acidosis, the PaCO₂ should also reduce. So by how much it should have reduced? That is given by the formula which is called as your Winter's formula. So your Winter's formula is given as 1.5 into bicarbonate plus 8 plus or minus 2. Right? So this is your Winter's formula, which basically states that in metabolic acidosis, your respiratory compensation will be a reduce in the PaCO₂, reduction in the PaCO₂, and the reduction in the PaCO₂ is given by this formula. So you substitute this, no? You get 1.5 into 16 plus 8 plus or minus 2, and it will be in the range of 30 to 34, right? So what is the normal range of PaCO₂? It is around 35 to 45. So here you can see that the PaCO₂ is reduced. So this is the expected PaCO₂ that you should be having or your ABG should be showing. Okay. So this is about your compensation for primary metabolic acidosis. Now let us look at the next example. So here the pH is 7.5. So is this alkalosis or acidosis? pH is elevated, so this is alkalosis. Okay. Bicarbonate is 32. What is the average bicarbonate? 24. So what is this? Bicarbonate is also elevated. What is the primary acid-base disorder? This is a primary metabolic alkalosis. Agreed? Yes. So this is a primary metabolic alkalosis. So what should happen to the PaCO₂ in your primary metabolic alkalosis? In your primary metabolic alkalosis, the PaCO₂ should increase, right? So this is what we expect, the PaCO₂ should increase, right? So what will be the expected PaCO₂? Expected PaCO₂ is given by this formula. Expected rise in the PaCO₂ for a metabolic alkalosis is given by 0.7 into bicarb plus 20 plus or minus 5. So in this, okay, forget this, we will be looking at this a little later. So you just substitute your bicarb, you get 0.7 into 40 plus 20 plus or minus 5. So this is 48 plus or minus 5. 48 plus or minus 5 is your expected PaCO₂. It is your expected PaCO₂. That means that because the patient is having a primary metabolic alkalosis, the body should have hypoventilated and increase the carbon dioxide concentration in the patient from up to a range of 48 plus or minus 5. But in your ABG analysis, what is given? What is the actual patient's PaCO₂? So the actual PaCO₂ is 40. What is the expected PaCO₂? The expected PaCO₂ is 48. That means what? That means there is some amount of carbon dioxide washout that is happening. That's why the PaCO₂ has not risen that much. So there is some carbon dioxide washout that is happening. Or in other words, what is carbon dioxide washout also called? That means there is some amount of respiratory alkalosis. There is some amount of respiratory alkalosis. Okay. So finally, what is the diagnosis in this patient? There is metabolic alkalosis and there is some amount of respiratory alkalosis because there is no adequate compensation. The adequate compensation is that the carbon dioxide should have raised to 48, but it has raised only to 40 as per the question. Why is that so? That is because there is some hyperventilation or there is some carbon dioxide washout that is happening. So this is your metabolic alkalosis with some component of respiratory alkalosis. Alright. So we have looked at the compensation for acidosis, we have looked at the compensation for metabolic alkalosis. Now let us look at the next question. Here the pH is 7.1. So what do you think is the primary acid-base disorder? The primary acid-base disorder is your acidosis. So your primary acid-base disorder is your acidosis. The PaCO₂ is increased. That means what? It is a respiratory acidosis. So it is a respiratory acidosis. So in a respiratory acidosis, what do you think will be the renal compensation? What will happen to the bicarb? Because there is acidosis, the bicarb will start accumulating. So what should happen? This is your expectation. Your bicarb should increase. Okay. So expected bicarb, for every 10 mm rise in the PaCO₂ from the baseline, the bicarb should raise by at least 1 unit. Let us say that this is an acute respiratory acidosis. Correct? We have learnt it in your respiratory acidosis chapter as well. So here, what is the raise in the PaCO₂? Let us take that the normal PaCO₂ is 40. In here, the given PaCO₂ is 60. So by how much it has raised? It has raised by 20 millimeters of mercury. So if the PaCO₂ raises by 10, then the bicarb should increase by 1. Here the PaCO₂ has raised by 20. So the bicarb should have increased by 2. This is basic mathematics. So the bicarb should have been increased by 2. So the expected bicarb should have been 24 plus 2, which is 26 milliequivalents per liter. Okay, but what is the bicarb here? It is 30. Here the bicarbonate levels are 30. That means it has raised beyond the expected compensation. So what does that mean? It has raised beyond means that there is a component of metabolic alkalosis. There is a component of metabolic alkalosis. So this is your respiratory acidosis with metabolic alkalosis. Which common scenario do you find it, right? So for example, a COPD patient admitted with cor pulmonale. Okay, so if he is admitted with cor pulmonale, he has an acute on chronic respiratory acidosis, right? He has an acute on chronic respiratory acidosis. Now, because of the cor pulmonale, there is some pedal edema, elevated GVP. So, what do you generally treat it with? You give him a diuretic. But over 2 to 3 days, what happens? The diuretic is going to remove your excess sodium and water, and you will have contraction alkalosis. You will have contraction alkalosis. So this is a very common clinical scenario where you can get respiratory acidosis with an additional metabolic alkalosis. So I hope it's clear till here. So we have understood why this is respiratory acidosis, right? Till there you have understood. Next is, what was the expected rise in bicarbonate? Expected rise should have been only 26, right? Because here the PaCO₂ is raised by 20, bicarb should have raised only by 2, it should have been 26. But here it has risen more than that. That means there is a component of extra metabolic alkalosis. Okay, so clear till here. So this is about your step 2, about your different types of compensation. Okay, let us move ahead. What is your step 3? It is the calculation of the anion gap and delta ratio, right? So delta ratio is calculated in your high anion gap metabolic acidosis, and calculation of anion gap is done to differentiate whether this is a HAGMA or a NAGMA, right? So HAGMA versus NAGMA we have dealt with in our chapter on metabolic acidosis as well. So the normal serum anion gap, just a refresher, we know that the number of cations is equal to the number of anions. So when there is excess acid maybe from outside like ketone bodies, or maybe because of sepsis there is lactic acidosis, right? So then the number of anions become more than the number of cations and you develop a anion gap. Okay. So the normal anion gap is 8 to 10, or some people take it as 8 to 12 milliequivalents per liter. So the anion gap is given by the formula sodium minus of chloride plus bicarbonate, right? So the number of cations minus the number of anions gives us the anion gap. So if this anion gap is more than 12, then this is a high anion gap metabolic acidosis. If the anion gap is in normal range, then you have your normal anion gap metabolic acidosis. Your normal anion gap metabolic acidosis we have dealt with in detail in your metabolic acidosis chapter. How do you obtain a corrected anion gap? The anion gap has to be corrected for albumin levels. The anion gap is given by, corrected anion gap is given by anion gap plus 2.5 into normal minus observed serum albumin. Okay. So in your acid-base questions, what will you do? First step is your identification of the primary acid-base disorder. The second step is your identification of the compensation. So once you have done both, the third step is the calculation of anion gap to determine whether this is your high gap or a normal gap acidosis. If it is a high gap acidosis, then you go on to your next step, which is calculation of the delta ratio. So what is the delta ratio? We had briefly discussed this prior as well. Delta ratio is given by delta anion gap by delta bicarbonate. So this is used to find out if the HAGMA has an extra NAGMA or a alkalosis. So mixed acid base disorders are present or not. You can find it with your delta ratio. So delta ratio is given by anion gap minus 12, change in the anion gap, right, by the change in the bicarbonate. So if this delta ratio is between 0.8 to 2, then this is a pure high anion gap metabolic acidosis. Okay, some people even take the ratio as 1 to 2. If the delta ratio is less than 0.8, then there is a HAGMA with a superadded normal gap. If the ratio is more than 2, then there is a high anion gap acidosis with a metabolic alkalosis. Okay, so this is about your anion gap. Anion gap is basically used in your high anion gap metabolic acidosis to determine if there is an associated normal gap acidosis or an associated alkalosis, right? So the normal ratio is 0.8 to 2. If it is lesser than that, then it is HAGMA plus NAGMA. If it is more than 2, then it is HAGMA plus an overadded metabolic alkalosis. Okay. Now let us understand this with the help of this example. So a patient with diabetic ketoacidosis has lab values as shown below. The pH is 7.1 and the bicarbonate is 16. So first step, what is the primary acid-base disorder? This is an acidosis, right? Bicarbonate is also low. That means that this is a metabolic acidosis. Okay, so till here clear. Then the PaCO₂ is 32 and the sodium and chloride levels are given. Fine. Next step will be, we have found out that this is a metabolic acidosis. You have to find out whether this is a HAGMA or an AGMA. So for that you have to see the anion gap. Okay. The anion gap is given by the formula sodium minus of chloride plus bicarbonate. Sodium minus of chloride plus bicarbonate. So this is 140 minus of 116, which is 24. So the normal gap is what? It is 8 to 12. So here definitely it is increased. So this is a high anion gap metabolic acidosis. Fine. Then you look for your compensation. The expected PaCO₂ is given by what? It is given by your Winter's formula. So here it is 1.5 into 16 plus 8 plus or minus 2. 1.5 into bicarb plus 8 plus or minus 2, which is 32 plus or minus 2. Here the PaCO₂ is 32. So yes, it is a compensated high anion gap metabolic acidosis. The expected PaCO₂ and the given PaCO₂ are same. So it is well within the range. So yes, it is compensated HAGMA. Now you have to see whether this HAGMA is associated with anything else or not. For that we do the delta ratio, which is given by change in the anion gap by change in the bicarbonate. So change in the anion gap. So what is the anion gap here? The calculated anion gap is 24. Normal anion gap is what? It is 12. By what is the change in the bicarbonate? The given bicarbonate is 32 and the normal bicarbonate is 24. So this is 12 by 8, which is 1.5. So this delta ratio is within 1 to 2. We have learnt that if the ratio is between 0.8 to 2 or 1 to 2, then this is a pure high anion gap metabolic acidosis. This is a pure high anion gap metabolic acidosis. Alright? Fine. So this is about your approach to your ABG. So what are the basic steps in the approach to the ABG? We have to look at the primary acid-base disorder. Then we have to look at the compensation to see if it's adequately compensated or not. In a metabolic acidosis, calculate the anion gap. See if this is a high gap or a low gap. Once that is done, you have to look for the delta ratio and see if there are any additional disorders along with it. So this brings us to the end of chapter on acid-base disorders. Thank you.